Hi, this is Tim Fairfield, Keysight Technologies. In this video, I'm going to show how to set up a 112 gigabaud signal running, and that includes the In System Cal to get a reasonably good signal on the screen as a good starting point, and then show some of the ways you can use the IQtools to generate signals. So let's get started. This is starting from square zero. When you have the M8199B hooked up, we're connected the data in, data outlines are going into the N1060. The key thing for the In System Cal, which we need to do first, is that we have a sample clock. We're using ref clock out 16 gig, and we're using the sample mark out going into the trigger input of the main frame so that we have a trigger signal for the tones. Before we get started, you need to launch the M8099B software because that has the instrument driver for the arbitrary waveform generator. What we want to do is choose the startup, the generic BERT AWG option. Let that launch first and make sure that it connects correctly before we proceed with anything else. And when that's up, we'll go with factory preset. We're going to start from nothing at this point. So we've got clock gen, data out. We don't really have to touch a lot in here. Clock in, we're going to leave that. The data out, go to the amplifier. If we do not turn on the output state, nothing's going to happen. So there's two places we need to do this. We have a global output and we have a channel output. So we see the output is half on down here, and then we turn global output. We should get something going out at this point if we have a signal chosen. However, we're not generating from here. We need to now launch IQtools. So we want to launch this. So IQtools is a MATLAB script that has a lot of flexibility. This one's pre-compiled. You can get the source code for this and make modifications on your own. What we want to do first is make sure that we configure the instrument, okay? So we go to instrument configuration. We have to choose our instrument model, M8199B, out of the list. We'll just leave this set, and we want to put the VISA address for this particular instrument. Where do we get that from? You can use localhost since we're running on the same machine, or you can put the actual address. Let's try, if we try this connection, so probably the best way to get the VISA address, go to Connection Expert, and these are all Pixie model numbers, so we're actually going to go for the frame. We want to go to the M8099B. So what we're going to do is add a LAN instrument, enter address, localhost. High slip is a better protocol for speed. We can test this VISA address and it should come back with something. And let that run. So now we have this. We can copy this address and then plug it in here. You could use the actual address that you would get as well. We're going to do this. We're going to test this connection. Should go green. If it does, that means we're talking to this module. I've got sample marker to sample rate divide by 16, so I would recommend you leave that there. Most of these else you don't have to touch. The other thing is for In System Cal, if we have a DCA, we need to put the DCA, the sampling scopes address here, and test that connection as well. So in this case, we have the address for that. If you're using a real-time scope, you would put that address here and test that connection. So we're going to test this one. This we've already got here, and what we noticed is under remote control, this means that we are connected to it. The next thing we want to do, you could go do one of two things. What I like to do is just make sure I can generate a signal of some sort on the screen. What we're going to do is we'll do In System Cal in a minute, but what we're going to do is serial data generation. Make sure we can generate something. So let's pick something. Let's go 112. We can get aggressive and go 112E9. And see if we can do that. Let's just do an NRZ pattern, a PRBS 2 to the 9, something like that. And maybe we can do 56E9. Let's just do that, 56E9. Let's see if we can get something. And we're not going to apply correction, that's afterwards. But let's just try this and see if we can get something to generate. It'll download the waveform and it'll control this on the back end. So we should be getting something on the input, but 1A has an optical module. Our actual modules that we're interested in. I'm going to have to go back to local mode so I can control things. Let's turn on this differential mode. It's obviously going to get the wrong speed here because we haven't set anything up correctly. Let's turn off 1A. Let's just turn that off. I don't want to see that. I do want to see differential 2A though. Close. We are getting a signal of some sort. We can auto scale, and we can do, we're just doing a, let's do frame trigger, and we did 56E9, I believe. Gigabaud. Let's try that. Close, auto scale. All right. And see if we can pattern lock on it. Something's giving us a bit of a problem here. Detected trigger. So in any case, I think all we want to do is a sanity check is that we've got something going on here, because I've got the triggering set up a little bit different. Let's see if we can get this to behave properly. It's 56. Auto scale. There we go. All right, there we go. We got it's ugly, but we're getting a, and then pattern lock should work now. Yes. Okay. There we go. So we got pattern lock now, 56 gigabaud CDR. All right. We get some sort of signal. It's pretty ugly, but that gets us going. The next thing we need to do is I want to run IQtools. Let's go back out. So if we go back to IQtools, we want to go to the In System Calibration. So what this will do is allow us to sweep a bunch of tones and essentially do some equalization on the signal. And so we're using a DCA. If we're using a real-time scope, we'd go here and use the scope channel. We're using a DCA, and I'm on differential 2A. We're going to leave this PTB, press run panel. So we need something connected to the PTB in the front panel. I don't need to select any of these. What I'm going to do is run this, and it's going to get a plot for us. And if everything goes well, we should see some activity on the screen, which we do, and it will do a plot. So this is what we want to see, which is good. It's doing some captures, and let that run. Now this calibration or in system cal only needs to be done once. If you change cables, move cables, had to retorque, I would recommend doing this, especially at the higher speeds. You can also set the max tone frequency as well. So you have some adjustments on how many tones are used. I'm going to go overwrite and then leave this and then go back in, and we're going to try to generate. So we should be calibrated up, and we're going to go back to serial generation. If we go to serial data generation, we're going to go 112E9. We're going to go to PAM4, and we're going to go to PRBS 2 to the 13, PAM4. We can use transition time or raised cosine. When we're generating this, what we want to do is apply the correction, and we don't want to be sending to channel 2 because we don't have that. We can show the correction that's going to be applied. That's what we want. So we've got that, and we can actually add S parameters in there, but I won't show that on this video. And then we can download our waveform. Oh, I got a problem up here. I did not enter that correctly. 112. It's turned it to a raised cosine filter for us. And again, let's fix that up. It's going to readjust the number of symbols, and we'll need to have this number when we're doing some setup. So we've got something generating here, frame trigger. So what we want to do is we want to use external precision time base, and our source is a ref clock. It's a 16 gigahertz. So we got to set that. We're not going to enable it yet. And then the frame trigger is going to be PTB. We're going to do that. Acquisition waveform. I'll leave that for now. Full pattern off. Get the 16 gigahertz and pattern lock setup. So the symbol rate is 112 gigabaud. I generally will set this manually when we're at the higher speeds. Integer or fractional we can choose from. Let's go with this for now. We're going to put the pattern length as this, and we can leave that for now. Let's see what we get when we try to auto scale this. Oh, and we may have to deskew this. I did not. Advanced auto deskew. That should help us a little bit. Did it help us? A little bit. Let's add the system, the impulse response correction. So that's a really big one that we have to adjust. And let's go to this, but we want to configure this to be a flat response for these higher speed. And let's make this 100 gig for now. That should really help things out. There we go. So we get a much better setup. And what else do I want to do a measurement on? We can start by going to the PAM settings and go to TDEQ. Okay. Can go back here and then to the 80. Stay with flat. Let me improve things a little bit. Yeah. So we need some more filtering there. And if we wanted to, we could take some signal processing and check out this. So we can do a sin X over X, connect these, put it on an output, go back in here. Recalculate these taps. We can also go to, not there, but 80. No, let's like clear. So just clear out some of the noise. And put that down. It's a slight improvement. We can compare these two visually this way. And we can run a TDEQ on that and see what we get. That's a 21 dB. We could take these filters at this point that were calculated. If you wanted to play with the cursors, I'm going to do one more measurement. I'm going to take a TDEQ, put it here and put it on blue, recalculate these, close, and just drop this for a second and mark that and see what measurement we get there. So we get a 38 dB here. Now we could try and apply the taps that we got from here onto this signal and see what we get. I'm going to try that. The way to do that is we can go in here. We get TDEQ EQ. We've got 3 precursors and there's 5 of these. So we're going to put 2 at the end and 2 at the beginning. I'm going to take those numbers, and we're going to enter them here. So precursor 0.000368 space 0.004204 space negative 0.013229. And then the other ones are going to be 1.021301 space negative 0.012643. Let's see if I did that. Oh, it's complaining. What did I do wrong? Oh, it's 11. Try. I think I did it right that time. Okay. See what that transpires. Auto scale. There. So now we went from, this will optimize again automatically. So now the D2A is at a 0.37. So that's better. We're getting a very low number here on the yellow where we added the extra filtering, and these taps auto recalculated again. So if we were to go back in here, we can see that now these taps have been recalculated. So it does it on the fly, which is nice. And you can observe you can add more of these kind of processing in here, but we've pre-distorted this to get a better choice. So that's where and how you do that here. You've got a few choices here. You can change your pulse shaping filter if you want to, like a raised cosine. I can download that. That's probably not optimal, but if you are familiar with making those changes, I think somebody told me to use 0.3 or something. I don't know. So did we improve things here? Let's take a look. Maybe, I don't know. Anyway, so that's where you would make those adjustments. And you can also do a visualize to see what is coming out. I'll get into the visualization if you want impulse and stuff like that. If you get the source code for this is the pre-compiled version, you can get the source code, but you have to own the MATLAB software to go in and modify all this if you want to make it more customizable. But this has a lot of tools right out of the box. Okay, so one question is we're using IQtools, and if we go in here, we don't really see an amplitude setting. The normalized amplitude has to do with the DAC, so we generally don't play with that too much. What you have to do in this case is go to the parameters of channel 1 data out. So let's say we were in here, we go to data out, and we want to adjust the amplitude here, and if we go to 0.6, or actually 0.6 volt, we see the reduction in the amplitude. So this is essentially where you would do that. You can hover and dial as well. This is real-time feedback because it's an analog control. So you could hover and roll with your mouse wheel. You can enter the values. The max is 2.7 volts. I won't go that high on a DCA because we could damage the front end. Though we don't want to do that. So we want to stay in the 1 volt range. Just put 1 volt for it. Or 800 millivolt. Let's put 800. Oh, there. Okay. So that's the amplitude control. So I think that kind of goes through the In System Cal, getting the 112GBaud on the screen, PAM4, and then making some adjustments and visualizing it in a couple of ways, and that should get you started.